Hey guys, welcome back to the channel. This will be a part 2 on the 3.8 Mustang build for this 95 Mustang. My next step is to get the heads done so I can get the heads reassembled and bolted on. Right now I got one soaking, one's fully disassembled. Soaking in a tub of extremely hot water and Tide, believe it or not. We've had really good luck with Tide. So it's about 8 gallons of really hot water and 2 capfuls of Tide. I don't know if you've ever had your hands like incredibly greasy and you're using the pumice soap but it's still not taking it off. Take like a dime size of Tide and watch how clean your hands get. It's incredible. But I have this other head right here that I just want to show you guys before I fully disassemble this one too. How to get these valve springs out. Doing valve seals and then I'll lap these valves when I'm putting it back together also with new valve seals. Here's kind of the lay of the land over here. So I mocked this towel, driver's side, passenger side. Everything I work on, I'm just in the habit of, the wall is the rear of the engine, coming towards me is forward. But I like to mock everything and put everything in line, how it came apart. So when I put it back together, everything goes right back where it came from. Not that it even matters. I mean, after you lap these in, you probably don't even have an issue, but mixing them up. But I like to, if I can, wherever it comes out of, I like it to go right back where it was. If it worked before, it'll work again. So the next step is taking these last 2 valves out, and then I'll dunk this one. So I'll just show you how I use this. It's a really old school valve spring compressor tool. It's pretty cool though. I like that it's old school and it works awesome. It's not pneumatic, it's all done by hand. I actually almost got really lucky using the LS spring compressor tool, but it was just, the angle was off just a hair where it was kind of racking the valve and I couldn't get it out. So I'll be using this old guy right here. All right, so this tool's really straightforward. Obviously this end goes on the spring. You just want to make sure that it's seated. You want to open this guy up first. Hold on one second. So pulling this handle down, it's going to open up, and then as you're closing it, you'll actually hear it snap towards the end, and that's going to fully compress it. And then right here, this grip, I'm going to put my hand under it and pop it up to release the tension, and then it'll spring open again. But it's all mechanical. You're just using leverage to compress that spring to get those keepers out. So I'll open this up wide. Get that on the spring, make sure it's seated on the spring correctly. I'll hold that on, start closing this handle on the valve, and then you'll hear it snap as I close it. And if you look, the spring's compressed enough to get these 2 keepers out. You can use a magnet too. And then to release it, I'll try releasing it while holding the head, but I usually use 2 hands. So it's released, and there's a spring coming up. I'll pull back, and there we go. It's a little difficult trying to hold the head while you're doing it. You'll just keep it on the bench. I'll do the next one. I'll show you how I do it without trying to get it in the camera. So take the spring off. Get the top hat, which fell probably away from me right here. I like to stack everything how it came off. So put that off to the side. This will all get cleaned also. And then we'll just push the valve out. I'll inspect the valve quickly just to make sure there's nothing completely marred. If there's something in bad shape, then I mean, you basically just want to quit the DIY. You're heading to the machine shop. And the whole purpose of this this video is all DIY in the garage with basic hand tools. So far so good. We've been doing it. All right, get this last guy apart. Same thing, get that lined up and square. It snaps. Get the keepers out. Sometimes you gotta roll them. The valve stem could be kind of leaning towards one side. You can't get the keeper out, so you just want to roll it to where you can get it out. That's it. Take your spring off, This is the seat. This is always against the head. This is your cup to hold the spring. And then you have your top hat. That's your full assembly against the head. And all you're doing is compressing that spring to get those keepers out. Same thing, I'll pop the valve out. And there's the grooves that the keeper sits in. If you've never seen this before, I'll just show you quick. This is a half a keeper. See if you can see that. And what you're doing is just putting that keeper right in the grooves. And it's tapered. So when you release the tension, that taper is going to fit down into that top hat and hold it nice and snug. Been doing it like that for a very long time. And so that's that. And then now we want to get these valve seals out. Again, super straightforward. The valve seal on the inside has a rubber seal, and these are just pressed on. I actually have a tool for pressing on LS valve seals. It's going to work just fine on this. You can actually just put them on and use your thumb and push them on, but the tool is nice because it's grabbing the jacket around the edge and it's pushing on that, not on the rubber seal. And this seal has like a little garter spring around it, holding it tight against the valve stem. But to get these off, super easy. Just use a pair of pliers. You don't have to use a ton of pressure. You just want to get it moving first, get it to rotate, and then you should be able to just grab them. Just wiggle them right off. Do the same thing with this guy. Get it moving. There we go. I should be able to do the same thing, wiggle it right off. So that's that. I'm gonna dunk this in the my little makeshift hot tank over here, let it soak for a while, and when it starts cooling down where I can actually get my hands in there, I'll start scrubbing with a bristle brush to try to get all this stuff out of here. And then I'll take them out, hit it with the pressure washer, hit it with compressed air, then last but not least, I'll hit it with a couple cans of brake clean, blow it out one more time, and then I'll be ready for assembly. All right, the heads are all cleaned up. I gave it the Tide hot water bath inside that tote. I pulled them out of there, lightly hit it with a wire brush just to get some of the stuff off in the corners. It came right off, so I spent maybe 5 minutes just hitting it with the brush. Not even. I ended up taking them out and laying them on a piece of cardboard, and then I just hit them with the pressure washer, and it took everything off. The next thing I'm gonna do is hit it with brake cleaner and then compressed air before I mount them. But before I do the final cleaning, I'm going to stone these surfaces, prep them for installation. So I'll hit the head surface, the intake surface, and then the valve cover surface. Then I'll soak them down with brake cleaner and blow them out really good before I install them. I think what I'm gonna do before I put these heads on though, I think I'm gonna clean that cam up, install the cam, and the timing set. I'm thinking it'll just be a lot easier to not have to fight the compression. I mean, I can leave the plugs out, but to be able to see top dead center, it'll be a lot easier with the heads off to get this timing chain set up on and installed. So I'm gonna do that next, get the cam in. I'll hit it with some break-in lube, install the cam, get the timing set on there. Then I'll move on to the heads. All right, I got the cam all cleaned up. I got the assembly lube on. I'm not gonna be able to obviously film putting it in because I need both hands. I'm gonna put some gloves on and just smear this assembly lube all around the camshaft and then stab it in the block. All right, so I got the cam covered in assembly lube. You wanna make sure you have it lubed up very well during startup. The first 10 seconds are pretty critical. You wanna keep this very square the whole time. You don't want to force it. And as you're going through, you want to hold all the weight. Take your time. You don't want the lobes nicking the bearing. Luckily, this cam, I don't need a handle. It has a pretty big snout on it. So we got one more. You can take a break for a second if you need to. All right, we're almost there. And that's it, we're in. Just want to make sure it rotates freely, which it does. You're gonna have a little bit of friction just because of the assembly lube, but that feels really good. So the cam is in, and what's nice, I just wanted to show you guys, this is #1 cylinder. We want to get it on top dead center, and that key needs to be pointing straight up and down. That's where the mark is on the gear. And what's nice, with the head off, you can actually watch top dead center. You'll see it actually stop, and then you have to go a hair more, which is actually, it's meeting its fulcrum, where it's that the piston's basically floating on the rod. That's top dead center. So I'll just keep going here and see if you can see it. So right now, it just maxed out. And right there, I can go a hair more and the piston won't even move because it's just changing the fulcrum. You can see the key, I have a hair more to go. So I'll just give it a little more of a bump, which I did. I actually wish I had it held higher. You could have saw the other piston come down, and this piston didn't move at all. So that's true top dead center. And then this key is pointing straight up and down. So that's where we want to be on the crank. So now I can put the crank timing chain gear on, and then I can align the cam. And the cam, basically you want both these lifters. So you want to be on the power stroke with both the intake and the exhaust closed. So we can look right inside and look at the cam where the lifters would be, and we want to be on the base circle, which is the very bottom of that cam lobe. Well, I'll show you when we get there. All right, so here's the bad motor that's still assembled. I never took it apart. And if you see the key straight down, so it's actually key to key, which is, I mean, pretty helpful. It's kind of a dead giveaway. So key to key, and then we come over to this one that we were rotating, and we ended up pretty much in the same spot. I mean, almost dead on, key to key. So just thought that'd be neat if you guys have never seen that before and what top dead center is all about. All right, next step is to get this timing chain set on. I ran into a little bit of a dilemma. This is the set that came off the motor that actually came out of the car with low mileage. It looks like it's in great shape. The pot numbers are different on the spacer for whatever reason, and the cam plate itself. So these are the ones that came off the salvage motor. So I'm going to reuse those. I looked up the timing chain sets, and the part numbers are exactly alike. So those are interchangeable. I'm gonna show you, this is the set that came out of the motor we're rebuilding right now. And I don't know if it just looks like baked on oil from sitting or whatnot, but I don't know, the mileage is unknown. It said it had 90,000 miles on it, but I'm not 100% sure. And I'm not 100% sure the last time it ran. I do know when our original motor last ran, so I feel a little more confident in using that set. And this is the set that came with the kit, and I don't like it. It's new, but I just don't like the casting. I don't like the surfaces that should be polished for oiling. They're not polished. Like I said, they cast. I'm not sure about this chain. It's just cheap parts from China, you know. This parts kit, that number TK4116, I looked that up, and it was like a $35 kit. So what I'm gonna do is go with the set that came off the original motor. I know it'll work. Like I said, it looks like it's in good shape. It's not a belt, it's a chain. I mean, this set's gonna last the life of this car, to be honest with you. The only other thing I gotta think of is the damper. This one that's in this engine, just so you can get an idea of how this works too. So when this is up, this rides against the chain, and that spring pressure pushes down inside of here as like a little cam. You'll be able to see it when I pull this back. So that little bump that's sticking out rides on here, like a little slide. And as you can see, as that spring pressure pushes that down, it's gonna push this out. And that's how you get your dampening against your chain. And there's a hole drilled inside of this. So before you take your chain off, while that's against it, if you take a pair of large water pump pliers between here and the chain, and just lightly squeeze, you'll be able to get that little cam in there to move up, and you'll see the holes line up. And you can put a pin in there. I put a obviously an Allen key works too, or drill bit. That's the right size, except mine are all smoked and it's probably 1/8 inch. So that's how that works. And if you allow this to open up without putting that pin inside that hole, you'll get to the point where that cam's actually going to ride down here. You have a 0% chance of squeezing this afterwards to get that to go up. You're going to have to start down here and try prying that plastic piece up without damaging it. So it's a can of worms. So you want to do that first. I'm going to use this damper off this engine. It's in good shape. It moves freely. The guides are still nice and smooth. They're not even worn in. They're still pliable. So I'm going to use this. If I order one, like I said, I won't have it for till next Tuesday. And I really want to get this engine back in this car within the next week. So that's what I'm going to do. I'm going to use this this guide, this damper. I'll get that off that motor, installed on there first, and then I can slide, actually bolt this plate on. I'll put assembly lube on it, both sides, bolt that on, torque them down to spec, put on this cam spacer, and then I'll slide the timing chain set on, and you want to put it on as an assembly. So you gotta have that sprocket, cam sprocket, crank sprocket already in the chain. Get your alignments lined up. You got the keys pointing to each other. We're at top dead center, so I should be able to pick that right up and just slide it right on as an assembly. So just to get an idea how this oiling system works, you can see that behind this spacer. So when the spacer is against the block, against the cam plate, that hole right there lines up perfectly with that spacer, this polished surface, and then this cam sprocket would go on. This is the back side that'll go against that plate. And then you'll see these slots that are machined out and right down the shaft. So oil hits this surface, wicks through here, comes out this way to oil the timing set, and then starts following the shaft to the other side. And you'll see that machined slot. So it's slinging oil out to the chain, and it's also going against this bolt on the cam sprocket itself right here. So this cam sprocket's sitting there. That oil is allowed to go through that shaft, hit this bolt, and then on the back side of this bolt, you'll see the same thing. This washer has 4 machine grooves on it to allow the oil to spray out inside the timing chain cover to keep this all well lubricated. So you definitely want good surfaces, clean surfaces, machine surfaces for this oil to sling. So it's another reason why I'm not going to use that that China-made set there. I just don't like the quality of it. So we're going to stick with that guy, and we should have no issues. All right, so I got this thrust plate all cleaned up. I'm going to put some assembly lube on here, and then I'm going to torque this down to a 120 inch-pounds. All right, I got the cam thrust plate on, 120 inch-pounds. Looks good. Got some assembly lube on there. Next is the spacer. Just wanted to show you guys after it all cleaned up, you can actually see the machinist stone marks to get this nice and true, nice and flat for oiling, both sides. The stamping side actually goes against the cam thrust plate. So this will be the side that you see once this is on. But I'll put some assembly lube on here, get this guy on there, and then we'll move on to the tensioner. Timing chain tensioner is on. It's torqued down. It looks good. Next step is cleaning this gear setup. I'm going to make sure this front surface is clean and that back surface is clean. Like we said before, that's part of the oiling system. And it's also to get the oil to your camshaft sensor gear. So this is on the snout right here, and then from the timing chain cover comes your camshaft sensor. So you want to make sure that this is getting oiled. So you want those nice and clean before you install them. So just a quick tip, you could put the gear set on backwards just to hold it for you. You don't even need to line up the keys, but you won't lose your clocking. So if you had it laid down on the ground with your points, your timing marks lined up perfectly, you could pick it up as a set, put it on backwards to clean it and get your assembly lube on. And then I'm gonna spin it around, do the front side, and then finally slide it onto the keyways. All right, so we got the timing set all the way back, still got the slack in the chain. I'm not gonna release that until I have the cam bolt torqued down. So this is your camshaft sensor gear. So this is the last thing to go on. Same thing, assembly lube on the back side. I made sure this was really clean in the front. That's cleaned up. And there's those machined grooves for the oiling systems, for the oil to come out and sling into this cover. So this will be the last piece for that. Then we're gonna take this bolt here with the washer that has the grooves in it for oiling. Get this on. This has already been cleaned and lubed up. I'll put that on, torque this down, and then we can pull that pin for the tensioner. All right, I got the cam bolt torqued down to 36 foot-pounds. So now I can release this tension. See if I can pull this with one hand. Yep, so we're good. That just released, that spring pressure's pushing down like I said before, and now there's no slack in this chain. Just for a quick visual of what the cam sensor's doing and how it drives the oil pump. So this obviously goes through the timing chain cover. That bottom stem goes into the oil pump to drive the oil pump off the cam. So it's doing two things at once. So that camshaft's turning that gear right there, which is giving the signal to the cam sensor, and it's also driving this shaft that's inside the oil pump, turning the oil pump. Just thought it'd be neat to show you how this actually lays in there. Go.
These are the lifters, well, the new lifters, and we're soaking them in the oil so they get oil in them. And this is the part number.
All right, so while the lifters are soaking, I'm moving on to the heads. So these heads have been cleaned. They took the Tide bath. I scrubbed them down and then hit them with the pressure washer. So now I gotta actually clean up the mating surfaces. So this one I haven't done yet, just to give you a comparison. There's still some stuff that needs to be removed. And then here's a head that I've hit with the sharpening stone. I use the stone, this guy right here, when I do aluminum heads. I never put a scraper on it, razor blade. If you dig in, it could be game over, you know, if you get a good nick in the right spot. So I just use this stone with WD-40. I put WD-40 on the stone. I put it on the head, the mating surfaces, and then you wanna go, if you can, in an 8 figure, like a crazy 8, or at least in circles, but constantly turning the stone, so you're never digging in and making an edge so that the stone will stay flat. So I'll do that 2 or 3 times. So as you hit it, the stone will actually, some of the material will end up in the stone. So I just put it over the trash can, hit it with brake clean, clean it, oil it again, clean this surface, oil it again. I'll do that 3-4 times to get to where we're at right here. So this is a nice smooth surface. I'm not gonna go any more than this. You'll still see some staining here and there. And then you'll see like the fire ring inside the the head gasket kind of imprinted. That's fine. You don't want to take off any material, and you want to keep it smooth. And what's nice with the stone being flat going across the surface, you'll see your highs and your lows, and then you can actually stone those right out. But it's a very fine stone. It's made by Norton. I've used actually that same stone for years now. So I stoned this head. Now I'm working on lapping the valves. You can see these two are done. You can see the consistent gray ring all the way around, and it's the same thing on the valves themselves. And then for comparison, here's one that I haven't done yet. All right, and here are the 2 valves that have been lapped in the head that I just showed you, and you can see the gray ring all the way around there and on this one. And if for comparison, this is one that hasn't been done yet. So you're just looking for a consistent stripe all the way around on both the seat in the head and on the valve itself. kind of see that right there. That valve lapping compound, I'll show you right here. This is the compound I use. It's a 80036. It starts off as a 120 grit, and as you're using it, you're grinding it down. It ends at 120 grit, so it's a fine grit for the final lap, and you'll hear the difference. It'll feel very coarse here. It'll sound very coarse, and the more you do it, it'll get smoother and smoother to the point where you're down to about 120 grit, and you'll get a nice smooth surface. All right, so you put some compound on the back seat of the valve, spread it across, and we'll drop it down into the seat. And then you take this tool right here. It's a valve lapping tool. You can buy these anywhere. I don't have the part number in front of me. This one's from O'Reilly's. It's actually not that good, but it'll get the job done. The suction cup's a little too stiff, so it keeps undoing. But if you see, it's a suction cup. It sticks right on there. And what you want to do is just put your hands like you're rubbing two sticks together. A little bit of downward pressure as you're rotating it back and forth. And you can hear it. It was really coarse. And it's starting to get like smoother, a light sound. It's that grit going from 120 to 220. Came off again. So it doesn't take much. And you just want to periodically check it. So you'll pop it out. I'll clean that seat, clean that one. If I have a nice gray consistent stripe all the way around, we're good. And that's pretty good. It only took a couple of minutes. You can see a nice consistent gray stripe all the way around. So that's half of them done, those three. I got these three to go. And then I'm going to clean this head up. I'll hit it with brake clean, hit it with air, put it off to the side for reassembly. And then I'll do the same thing to that head. And then once that head's done, I'll clean up all the valve springs and valve cups and reassemble these. All right, so all our valves have been hand lapped. They've been cleaned afterwards. I hit them both with brake clean, then blew them out with compressed air. I actually have this head fully assembled, ready to be installed on the block. Valve seals, brand new, have been installed. The springs, obviously, that's all installed. Just to give you a visual. Here's the back side, the end of the side. So this head's ready to go. Ready to rock and roll. Before I get too far ahead of myself on this one, just want to show you on one, maybe two of them, how to install the valve seals and get this fully assembled, which it's just a reverse process of how you took it apart, putting it back together, but just probably a couple tips and tricks in between. So this tool right here, actually, it's from BTR. I use this for LS engines, and it actually does work. For this head in particular, it's the same metric thread. So what you do is you screw this in, and then we're going to pop the seal on top. Could probably do this with one hand. You want to install these dry. I've actually lubricated them. There was some debate going back and forth, dry, not dry. Obviously, if you lubricate it, it's going to go on a lot easier. But I did have it happen to me personally, where I ran the car. It was actually on a Grand National. It ran good for a while, then all of a sudden it started smoking like a freight train. I couldn't figure it out. I popped the valve covers, and the seal, you could see through the spring, was actually up. And it rode the stem out, so it had literally no protection. All the oil was going right down and just being burnt. And I did install those with a little bit of lube. So since then, I've installed them dry, and I haven't had an issue. Yes, they're hard to get on, but with the right tool, it's not that bad with the right leverage. And I'll show you how I do that. So this tool is machined to accept the valve seal, and these actually fit perfect on here. I don't know if it's the same for all heads. I doubt it. But so you pop this on. And then I just use, because everything's round and smooth, I use a really long 1/2-inch extension. You put that through the eyelet bolt here, and then you have all this leverage to push down. You do have to hold this square as you're doing it. So I'm gonna have to set this camera up to show you. All right, so you got this screwed in, a few threads. Put the ratchet in, and then you want to keep it square. The valve seal tool, the black tool, as square as you can while you're pushing it down. You want it to go straight down. And it does take some effort in this head being so light. Yeah, I think that's almost there. Make sure we're square. And that's it. These do fit on very tight, but you can see that gap at the bottom, that's landed. That's right on. And you probably can't see in the camera, but you can look in from the inside and see the stem inside the seal bottomed out. That's one. This eye bolt actually used to touch. So with the LS engine, they went on a little easier. For whatever reason, these seals go on pretty tight. So I might have to actually put this in a vise to close it up to finish these, and I'm sure there's a correct Ford tool for this that'll, I think if this was a little bit higher, you'd get more leverage on it so you don't have to push so hard, but it's working. I think I'll be able to get these done. All right, try one more here. Same deal, just make sure your guide's clean, which this one is, they're all clean. Keep it square. Yeah, this one went on nice. That's that. So I did measure these, they're all the same size, but for whatever reason, this one went on like butter, this one struggled. But I'm gonna finish these up, and then we'll install the valves and the springs. All right, we got all our valve stem seals on. Worked out pretty good. Just that final probably 1/8 of an inch. I ended up using this as a driver and just tapping it with a dead blow to get them seated. But we're good. No damage done to the seals. Ready to move on. All right, so a little prep before I install. All these parts are cleaned and I've already pre-oiled them. So the spring, I already get a little bit of oil before I put this retainer on. Chain is cleaned. Same thing with the cup. I already got oil in the bottom of it. So I'll stack those. I'll get this ready on this side, the install side, with the keepers. And then the valve stem itself's already cleaned up, pre-oiled the stem. I just put a drop of oil, and then you just want to lubricate the stem so when you're sliding it in, it doesn't tear your seal. So you want to push in, and then you want to put your finger on the end of the seal, kind of pushing in as you're pushing the seal through. I don't know if I'll be able to get this with one hand. Let's see. All right, so I just push the valve stem through, pushes my finger back. There you go. So that's in. I'm gonna prop this phone up to see if I can get the how to use the valve spring compressor tool. All right, I'll try my best to get a decent angle on this. But this tool is old school, so you open it all the way up. Slide your spring on. And you get a small opening. You just want to make sure that retainer is fitted right. Let me see if I can grab this. Just like that. And you want to keep it square when you're compressing it. So you want to be straight on. You almost need a third hand to do this. So holding this with the phone, I'm not going to be able to compress it, but let's see if I can get this back here. All right. So I hold that. Start closing this guy up. The back side, the clamp side is going to go right in the valve. And then you just start closing this handle. And it'll compress right on. Yeah, just to get an idea. I don't know if you can see that. There we go, I can pick this guy right up. So with a compressor, we can get those keepers in. You can see the grooves. And then here's the back side, right on the valve. And you can actually adjust it if you need to while it's tight, like a C-clamp. You can either tighten it up to compress the spring more or release it. So we get these keepers in. Yeah, and I'll just release it a hair so that I can remove my hand and grab the phone just to show you. Yeah. All right. So the keepers are just starting to go inside that retainer. So now I'm going to start releasing this tool. You see the spring come up. And wedge those keepers in there. And then you can take the tool off. There we are. So we got one installed. All right, I'm gonna try this one more time. Hopefully this is a better angle. I'm just gonna get this exhaust valve in. Stem's already lubed up. Got the stem through. The cup's already pre-oiled and cleaned. So is the hat, the steel retainer up top. Slide that on. Grab our tool, pull it back to open it up, and then when you're closing it, you can see it clamp and then it snaps in place. So pull that out all the way. Okay, pull that back, start compressing, snaps in place. See if you can see that. So you can see where the keepers go. All right, grab our keepers. All right, I have those in place. Now I'm going to slowly release it. There we go. Another one down. Just want to make sure everything looks good. Nothing's cockeyed. We're in the cup. You want to look at the keepers, make sure that they're both level with each other. So you don't have one sitting too high. That looks good. So usually when I do these, I do them up on end like this, so I can have two hands on each side. It's just with the view, you're not gonna see anything. All right, so now that I got all the valves in, one last thing you want to do is take a dead blow and then just give them all a tap just to make sure they're all seated. And we're good. Just a quick peek so you can see every keeper is flush and level. Nothing looks obscure. All the way down the line. So we're good to go. I'm just gonna make sure these head surfaces, the mating surfaces from the block to the head are clean on both the heads and the block, and then I'm gonna install these heads. So another thing you wanna make sure is your dowel pins, that these are nice and clean. You don't want anything, you don't want any resistance when you go to torque these heads down, holding it off the surface of the head. So you want those nice and clean. So when you let it down, you're not really forcing it surface to surface. So I'm gonna install those, and then one last wipe down both sides, and then I'll blow it out with some compressed air, Then I'll lay the gaskets and install the heads. All right, so I got the gaskets laid on the head. These are MLS gaskets. These are really good gaskets, multi-layered. I've used these in a bunch of boosted applications without any issues. They hold up very well. They're actually reusable, although I would never reuse them. Even the Cometics, they're pretty expensive, but I replace them anytime I pop the heads off. These are directional. So you got the L for left. It's always from the driver's perspective. That's the industry standard anyway. So the R would be the passenger side. Another dead giveaway on this engine in particular, being directional, is the front coolant ports are blocked off to force more coolant to the rear of the engine. So if you had these backwards, there'd be a good chance you'd be overheating this block and taking the heads back off. So you definitely want to pay attention to that. You want these back ports open on a 3.8. This is a 1998 block, so I looked up the serial number just to be sure. So on a 98 block, rear ports, you want those open. All right, so I got the head dropped on. I got the head bolts in. They're just hand tight. I ended up going with Fel-Pro torque to yield bolts, factory style bolts. You never want to reuse torque to yield bolts. Once you stretch them, the chances of you stretching them again and breaking are high. But not only that, if you don't break them, there's a good chance you're not getting the clamping force you need because they've already been pre-stretched. They only really stretch once, and they're junk after that. So don't ever reuse your head bolts. They're pretty cheap. It's like $20 per head. I actually ordered a set thinking I ordered the set for the entire motor, and I only ordered a set for one head. So I'll do this one head for now, go pick up the other set after, and I'll get the second head torqued down. Another thing you want to think of, you want your threads clean, the holes cleaned out. So when I clean this block, I hit each hole really good with brake clean, hit it with the pressure washer, and blew it all out with air very well. You can even run a thread chaser down through them. You want really clean threads, and you want the head of the bolt and the threads lubricated with a moly. There's an ARP Torquin lubricant that you can buy. I just use the engine assembly lube just because it's got the graphite and moly mixed in with it. And the name of the game is to reduce all the friction so that you're actually torquing and stretching the bolt rather than fighting the friction of the fastener against either the threads or the head of the bolt fighting the surface of the head. So you want to reduce that as much as you can so you're getting the proper stretch on this bolt. The torque sequence for this head, for this engine, is a little different than what I've come across. These 94, 95 blocks had such massive, which is that one right there, had such massive head gasket issues that they were fighting to figure out a way to mitigate that. Then the 96s came out, 97, 98. 97 and 98 basically, they've had zero issues with head gaskets, basically non-existent. But the 94, 95s were very prone to blowing head gaskets. 96 was getting better. 97 and up through the split ports, virtually no issues. I shouldn't say zero issues, but and how they mitigated that was mostly through the head gasket style. They had an asbestos style gasket, 94, 95, and then they switched to a MLS style gasket. And I'm thinking that this torque sequence came out of the 94, 95 issues. The engineers came up with this. It's a little bizarre. I say that, maybe you guys have come across it on a bunch of different engines. I just haven't. So the first pass is 15 foot-pounds, all the bolts, then 29 foot-pounds, then 36 foot-pounds. And where it gets interesting is here, after you hit that third pass on all the bolts, 36 foot-pounds, one bolt at a time from here on out. You back that one bolt out 2 to 3 turns. If it's a long bolt, you torque it back down to 37 foot-pounds. If it's a short bolt, you torque it down to 18 foot-pounds, followed by 180 degrees on each. So I'm gonna start doing that now, and we'll see how it goes. All right, so we're at the point where we're gonna start doing some degreeing. I figured I'd show you this if you've never done it before. It's pretty straightforward. It's something that you just want to take your time with to make sure you have this set up right. So I'm at the point where I've done the 15, 29, 36, the 3 passes. It's all torqued down. I backed this one bolt out 2 to 3 turns, tightened it back up, torqued it down. This is a long bolt, so it's torqued down to 37 foot-pounds. And now I need to degree it 180 degrees. So I just use this kind of an old school degree wheel here. And you set this arm, let me show you. You put this arm in, and you got a thumb screw to tighten it up. So this arm's fully adjustable. One side's short, one side's long. I'm using a longer socket, so I need this longer reach to get down to touch anything that'll hold it rigid and stop it. So if you see, I'll take it. This is tight. I'll push it against this casting, and then what I'll do is now all you're going to be moving is the wheel when you're turning this. So I'll just turn just the dial to get to 0. And now when I put the ratchet in here and I go to twist this 180 degrees, it's going to do exactly what I was just doing with my hand on the wheel itself, except it's going to be turning the actual bolt, the socket and the bolt at the same time. So it's pretty easy. You can't really mess it up. The only way you can mess it up is if you think you have it against this. Say you take the arm and you just push it against, and you're like, oh, I'm good, and then you set it to 0 without pinning the arm against something that's not going to allow this to rotate while you're rotating it. So you could be off a few degrees before you even start. So you want to make sure that that's against there, and that you're using the wheel itself, so that you know you can't drive this arm any further back, if that makes sense. Probably a horrible way to explain it, but I hope that makes sense. Like, I'll do it again. If I turn it all the way over here, instead of using my hand to kind of pin it there and then set it to 0 while I'm holding the whole assembly, if you just use the wheel, you're gonna watch the arm's gonna go all the way until it can't go anymore. Now you know that's enough friction to hold it there. It's nice and steady. Now I'm just gonna dial it to 0. As you can see, it does move around. But tightening it down by the wheel, it's just an O-ring underneath this head is the friction you're fighting. So you can actually oil that too, make it a little easier. I'll go right to 0 again. Now I know when I put that ratchet on there, it's going to do exactly what I was just doing right now, because it's the same friction on this device anyway, not the head of the bolt, but the degree wheel itself. Hopefully that makes sense. All right, so I got this one head done. Wasn't too bad. As you can see, the marking, what I did was I used the degree wheel, but what I did was I marked just one edge with the red paint marker, went 180 degrees, so I had basically 2 means to look at it. I watched the wheel, and I also would just watch this mark just to make sure that I really turned that head and stretched it 180 degrees, and then I put a line through it. So a complete line was, I was done with that one as I moved on. So it was 1, 2, 3, 4, 5, 6, 7, then 8. Just for a sanity check. For myself anyway, I lose myself as I'm halfway through this process thinking about 100 other things. So it's good to use a paint marker. Keep yourself in check. All right, so I got the passenger side torqued down too, same as the driver's side. Everything went smoothly. Next step is getting the lifters in, push rods, rockers. But before I can do that, all that oil is obviously going to drop out into the valley and through the bottom of the engine. So I really want to get the base pan on, but in order to do that, the timing chain cover has to be on first. So looks like we're going to be putting the timing chain cover on, followed by the oil pan, and then we can finish reassembling the top end. So we talked about this earlier. This timing chain cover is off the 94, 95. 96 through 98 has this style, and the big difference is the water pump. The bolt holes to the block do line up. Those are the same. But here's the smaller water pump going on the original timing chain cover from 94, 95. If I try putting that on here, it's not even close. So we're going to end up going with this timing chain cover because we want to use the bigger water pump, and I bought a brand new one. There's a reason for that. The 94, 95s are notorious for head gasket issues, so you could tell that this is larger, which is pumping more volume of coolant through the block. So we're gonna go with the original timing chain cover, which is also, I got a brand new oil pump, but the oil pump design is also different for this cover. It still will use the cam sensor shafts, even though the top connectors, the sensor themselves are different. They are interchangeable. So there's a lot of little caveats that you got to think of. So you just got to take your time as you're doing things like this. We're taking two motors that are somewhat similar and trying to make one out of them. I'm starting to think that there's more differences than similarities, but it should work. I think we're in pretty good shape. All right, so the crank sensor mounting bolts both broke on me. This timing chain cover isn't in the greatest condition. It's oxidized. I think it'll clean up well. I'll be able to clean all the mating surfaces and reuse it. But the biggest problem is those two studs breaking off inside the cast aluminum. So what I'm gonna do is I'm gonna hit this with the welder, the MIG welder, high heat, and just do quick short bursts to build this stud up. And then I'm gonna drop this nut on top of it and weld the built up stud to the nut, and then put a socket on it and try to back it out. Done this before for exhaust manifold bolts on aluminum heads. I've never done it in this case, but I think it's worth a shot. I'd rather try this first before drilling it. I don't want to drill all the way through this cover. I tried looking these up and they're like $250 for a new one, so let's see if I can salvage it. So you can see the ball that I put on it. I just kept tapping it, letting it cool. Right when the orange is about going away, tap it again. If you hold it with that high heat, it's going to just drop on you. So if you want to build up, it's just quick hits, on and off, on and off. All right, so now I'm just gonna take this nut. Now I can drop it on there. You can see now I got something to weld to. So again, just really high heat. I'll fill that in, and it's doing two things. It's also heating the stud, heating the aluminum, hopefully breaking it free by heating it up and cooling down. So we'll see what happens. All right, so I threw some weld in there. You can see it. Again, high heat, just pulled it in there. So now I'm gonna try putting a socket on that and taking it off. I have had it before where I built it up first before I hit it with the heat to fill the void in the nut. It just breaks off, and I'll just build it up again. I've had to do it before 2-3 times before finally getting it to extract, but let me see what happens. All right, so one down, one to go. I was able to get it. It was basically flush with the aluminum too, so with the high heat, I was able to build it up, get that nut on. It did. That's the third nut I welded on. This was the first one. Ended up breaking off right where I was building it up. Then second one, same deal. Broke off right where I was building it up. And what I did on this one is I did the same thing, built it up, just kept hitting it with quick taps, high amps. Once I got the nut on there, I ended up taking MAP gas and I heated up all around the threads and got it pretty cherry red. I figured if it was pretty much my last attempt. If I couldn't get it, I'm gonna have to drill them. But I was able to get it. It's just really hot right now, but it's coming right out, no problem. So I'm gonna try doing the same thing to this guy, see if I can salvage this timing chain cover. All right, same deal. Got the I built it up, got the nut welded. I'm gonna hit that post, try to keep it nice and even. I'll hit both sides, get it nice and hot. See if I can get this guy to back out too, which would be huge. All right, so we got some success. I was able to get that one to back out too. So I'll be able to salvage this cover. I'll clean it up, get this installed so I get the base pan installed. All right, so I got the new seal in. Also these studs, these are the ones that we heated up and welded to get out. Threads are still good. They're actually perfect. So that's gonna be a wrap for this one. I'm gonna make this a part 2. I have a couple of weeks before I can work on this again, so I'm gonna kick this video out. But if you like what you see, think about subscribing and giving it a thumbs up. See you in the next one.